Awesome. Who here is not from Norway? Okay. Who here is not from Europe? Okay, so there's a few of us. You're gonna hear an accent when I speak. I'm Canadian. So at some point, I will say about, and I think I said about. And when you say I did it, I'm gonna be like, that's not true. I also might end a sentence with a, like the presentation before mine was good, eh? And that means it's a question, but the only answer is yes. So if I do that, sorry, there's little Canadianisms that I do, and then I have to translate. So forgive me and my silly expressions that are bound to happen. I can't help it. I also, if I didn't get you with stickers on the way in, there's stickers on this chair on the way out. And there's a bunch of, how do I word this? There's a bunch of QR codes and stuff for different projects I'm doing in case you want to check out some stuff. Because I'm nerdy all the time, not just right now. But I think I can start. Yes, I got the little thumbs up. Awesome. I'm Tanya Janca. Thank you so much for coming. I'm so excited to be here in Norway. Usually, so the past 2 years I've come to Norway in January, and I like Norway better in May. Who here likes Norway better in May? Yes, it's the best. Thank you for coming to my talk. I looked at the other talks during this time session and I was like, oh crap, those all look really good. So thank you for learning about secure JavaScript with me. So what are we going to talk about today? We're going to talk about writing better, and by that I mean more secure JavaScript. We're going to talk about what I would like all of you to do and what I hope you will not do after today. And then I'm going to give you a list of a bunch of free tools that you can use to secure your JavaScript. And then I'm probably going to make fun of myself throughout the presentation, just generally. That's what I do. So first, a silly meme. How we describe the cyber attackers. There's a super advanced attacker. It's like really serious. And then it's like bozos in like dinosaur suits. It's, yeah, a little exaggeration there. So you're probably like, who is this weird lady in purple? So I'm Tanya Janca, and this is the mandatory about me slide. And for those of you that don't know, we have to do this slide as speakers. And do you want to know why that we do it? To try to say, I'm really competent. Please don't leave my presentation. Please listen to some of the things I have to say. So I'm going to try to convince you I'm competent. So I'm staff developer relations at a little company called SumGrep. They bought my company, and I like that a lot about them. I'm also known as SheX Purple. Purple is a security thing. I couldn't decide between defender and attacker. I kept doing both, and that is called Purple. I wrote some books, Alice and Bob Learn Secure Coding and also Application Security. I've worked in tech 28 years. In July is 29 years. I started the moment I was legal. It's pretty much mostly what I've done my whole life. I have done counterterrorism for Canada. I was the leader of security, so the CISO, for the 52nd general election where we voted in Trudeau with the hair. I have written and built lots of applications and done a lot of security. I started some things like some companies. I am an advisor for a startup. I'm a faculty member at ION's research. And hopefully at this point, you're like, she seems tolerable. I will accept this for now. Let's see about this JavaScript. Okay, let's go. So I really want everyone in the whole world to write more secure code. I've sort of dedicated my career to this, or at least the past 10 years of it. I'm pretty obsessed, like writing books, talking, writing, etc., all the time. And JavaScript runs the whole internet, basically, right? Like it's the front end of the internet. It's what makes things beautiful and responsive and amazing instead of a crappy static page. And so JavaScript's wildly popular. I love it. I'm assuming if you're in this room, you love it. But we also want it to be safe because we want to protect the people that use our systems. And so why does secure code matter? So you're probably like, I know. But for the one person that did not receive the memo, Secure code matters now more than ever before. Attackers have discovered that it's a really easy way to get in. So we are now really good at firewalls. We're really good at enterprise security. We still pretty much suck at phishing, but we're getting way better at everything else except secure software. There's a research paper that comes out every year, the Verizon Breach Report. And ever since I've been reading it in 2015, every single year, the #1 cause of data breaches is insecure software. Maybe it starts with a phishing attack or social engineering or some other stuff, but when they get in, they get the data, it's an insecure app. And so we don't want that. Like, our customers are demanding that things are secure. My parents bought a smart TV and they're like, don't worry, Tanya, it had a pen test. I'm like, yeah, that's right. My parents are learning. And so customers care. Now there's laws coming out. I'm in Europe, so you actually take this seriously, of GDPR, et cetera. You actually have a lot of laws. Like, you're a lot more serious than Canada is about it, but the world is changing. And so that is my spiel on that. So now let's do my 30 tips. And there's not 30, there's more than 30, but it doesn't sound cool like 36 tips. That sounds less cool. Anyway, okay, so the first thing I would like everyone to do is use a framework that outputs encodes for you. So we could use React, Angular, Vue.js. When we output encode, we take away the power of whatever we're putting on the screen. We're saying, do not interpret this. This is just text. And so what that means is you can't have cross-site scripting assuming you've done it correctly. Inside each of these frameworks, though, there are some gotchas. So for instance, you would want to avoid Angular's bypass security trust AS or AS. You would want to avoid dangerously set inner HTML in React. There are different things we want to avoid, and I'm going to go through a bunch of the things we want to avoid today, but I'm not going to deep dive into each of the frameworks, just into the core JavaScript language, because they said I couldn't talk all day, and that seems reasonable. Okay. Oh, there's going to be a lot of cute animals. Said that because there are. That's it. So I would like it if we followed a secure system development lifecycle. So this is the thing that I say for every language. So if we're doing DevOps, we're doing Agile, we're doing Waterfall, we're doing some sort of weird mishmash of those, or maybe we're wild and wacky and we're doing like rapid application development or something like that. Whatever you're doing, there should be security steps, right? Like, if you are going to do a design, it would be great if a security person could review that design with you. Or for instance, you could threat model it, or you could do security user stories. There's so many different things. So we could do threat modeling. We could have security requirements when we start a new project. We could do scanning, so like software composition analysis, static analysis, secret scanning, dynamic scanning. There's all sorts of different security tools. And I'm going to give you a list of a couple of free ones at the end. But basically, if we could do, oh, and there's more like secure design. So there's lots that I talk about on that. But basically, as we're building the software, if we can do security steps in each phase, we will build way better software, and it will cost less. So it might take slightly longer to develop it, but we will have way fewer problems later. Life is better when there's less bugs. So number 3, I would love it if we took cross-site scripting seriously. I suspect that you'll know what cross-site scripting is, but I'm going to talk about it briefly in case there's someone junior here, or someone who just like has had their head in the sand maybe, or someone who has like some misconceptions. I'm not going to talk about it forever though, don't worry. But ideally, to avoid cross-site scripting, we would do input validation, output encoding, and use the content security policy security header. But let me tell you a bit more. Cross-site scripting is the only attack that is designed just for JavaScript. That's the only place that it happens. It is, it's a form of injection. So you can have SQL injection, no SQL injection, LDAP injection, command injection. Like, there's so many different types of injection, which means tricking something that interprets code to thinking that the attacker's code is part of your app and that it should execute it and just follow their instructions instead of yours, which is really bad. And so it's supposed to be data, the thing the attacker entered, and somehow they've confused the app into thinking, oh no, that's code, I should probably go do it. And so when your app confuses the input as data, and then it interprets that code or executes that code, we have injection. When that happens in the browser with JavaScript, it's called cross-site scripting. It has its own name and its own entry in the OWASP top 10, and basically its own whole thing, because this is the only one that attacks our users directly. So all the other ones attack us. It attacks our data center, our database, our operating system, our whatever. This one directly attacks that nice person who's using your wonderful app. That's awful. None of us want that. That's terrible. And so ideally, just a second. So to avoid cross-site scripting, to repeat, we want to do input validation. And by validation, I mean we check that it is what we're expecting. And if it's not, we're like, no thanks. Please try again. So for instance, like, is it a date? Is the date in the proper range? Let's say you have to accept a string and it's a name, right? So I work with someone named Luke O'Malley. So he has a single quote in his last name. So I know I have to accept hyphens and single quotes because it's a name. I don't have to accept a whole bunch of types of brackets and other stuff. Cool. So I have an allow list of all the things that are allowed. I validate that it's in there. Then I might want to sanitize or escape the single quotes and the hyphens, because I know that I'm going to look this up in the database, right? So then we could escape if we need to accept special characters. Then we want to do output encoding. So we are stripping away the superpowers of this input before we put it on the page. And then on top of that, we use content security policy header. And that means listing all the scripts and other third-party resources that we're going to load as part of our system. And so if you did manage to miss something and you do have cross-site scripting, content security policy header would be like, yo, that's not on my list. No. And so this combination will stop cross-site scripting. And we're going to talk a lot of ways to avoid it throughout this talk. This talk's not only about cross-site scripting, but gosh darn, most of it is, because that's the main issue with JavaScript. Okay. So we would like to avoid inline scripting. And by that, I mean mixing our JavaScript right up in our HTML. It should be in a separate file. We do this because it's a best practice. We do this because it's better for performance. It's easier to maintain. It's also way more secure. When we mix them together, it is a great opportunity for cross-site scripting. It's not ideal. It is not what we want. If for some reason you are a rebel or just poorly behaved and you're going to do it anyway, ideally then you must use quoted data variables. So think source equals, and you put quotes around it to say this is text. This is text, treat this as text. This is data, this is not code. But ideally you just wouldn't do it, right? Could we like maybe all put our hands up and promise I will not do inline JavaScript? Could we just like, maybe, thank you. I'm seeing a lot of hands. Yeah, you in the back, you rock. I got 2 hands from him. Yes. Okay, so I would like us to treat input from the user as something that either we save or we display, as opposed to something that we use to make decisions. So I see this when I see, so when I do code review or security testing, I find security bugs because that is like what you do, right? If you're a security nerd. And often someone has taken something from the user and they're like, I'm gonna make a decision with this. And they haven't validated it first. So they're like, oh, that URL, let's follow the URL. That seems like a good idea. But what you should do is check it against a list of URLs that you know are cool, right? And so if we could always treat user input as something we are going to save or we're going to display, that would be great. That would reduce risk a lot. If you're not going to do that, you're like, I have to use it to make decisions, then I need you to proceed with more caution than usual and basically follow all the other instructions. Thank you. Okay, this is how injection and cross-site scripting happens. Okay, so now for some more specific things more codey things. So ideally, we would use text content or create element rather than using inner HTML or outer HTML. So basically, inner HTML and outer HTML are like, let's do some cross-site scripting. Like, they are such a huge source of cross-site scripting all the time. A lot of people don't use them anymore. Thank you, all of you. But if for some reason you are thinking of using one of these, they're dynamic. They're rather than static. And it's much safer if you avoid using those. Okay, ideally, we would use encode URI component or decode URI component rather than just escape or unescape. And the reason for this is because they break down each part of the URI for better safety, for more intentional use of that input. And so basically, there's a whole bunch of different attacks that focus specifically on URLs and messing with the format. So like the schema, like different fragment parts of it to try to trick your app into doing things it shouldn't. Server-side request forgery, which is one of those types of attacks, is on the OWASP top 10 now because it's happening a lot and it's very bad and we don't want it to happen to you. And so if we use encode URI component or decode URI component, it will break down each piece and check all of it and parse it more carefully. Ideally, we would use create element or append child rather than document.write. So document.write is old. It's not best practice to use it anymore. But on top of that, it basically helps prevent DOM-based cross-site scripting. So DOM, document object model, that is one of the types of cross-site scripting. So there's 3 types. There's reflected, stored, and DOM. And DOM means you have put stuff in the DOM that was not safe, and then later you pull it out and it blows up in your user's face, and everyone's very sad, especially your user. And so basically, text content and set attribute are much, much, much safer. They offer much more fine-grained control over elements, attributes, event handling, and they work with more modern frameworks as well. So like it's better performance, it's safer, it's basically a lot of win. Ideally, we should not use unescape HTML, and instead, we could use something like the he library or Lodash. Oh, wait, I thought I had more examples here. So basically, using unescape HTML is not really a best practice anymore. It doesn't really decode things quite right, meaning that it allows like dangerous characters in by accident. And like when we decode something, we want to avoid that, right? We want it to be 100% accurate all the time, but some special characters can trip it up, which then leads to the possibility of cross-site scripting. There's also just so many better functions that are more modern that you should use instead. Okay, so ideally we would use decode URI component rather than just decode URI. And so just like rather than using escape, if we use decode URI, like I said, basically it breaks down each part, like the port, the schema, and the address of your URI. And that helps you parse it correctly. And especially if you're going to check that and validate it against a list of good stuff, you want to make sure that you're parsing it correctly. It also, like, everything that lies between the separators, all those special characters is what it works on. So just a second. The component, or decode URI component, basically it's also capable of decoding even more characters, including a lot of special characters that you might need. And so you don't want to limit yourself by using just decode URI. Okay, so make sure to URL encode data before you pass it to the CSS URL method. So CSS is not smart, it's not a programming language, right? It's like a scripting thing. Or sorry, not a scripting thing. It's like a display thing. It makes things beautiful. I'm happy it does that. I suck at making things beautiful. I was never good at that when I was a developer. But basically, it's not CSS's job to do that for you. So you need to encode it before you pass it to it. If you don't do that, then it might have a bunch of special characters that lead to cross-site scripting, which obviously we don't want. It's not smart enough to handle that for you. Okay, so when we are in the execution context, and by that I mean we're playing around with the DOM, we should URL encode and then JavaScript encode. yeah, we have to do it twice. And yes, that sucks. I don't have like an answer to solve that. We have to do it twice because of the context that we're in. And so try really hard that if we are putting things into the DOM and playing around in there, that you're going to need to do it 2 times. Okay, so we would like to take away superpowers when we're between the script tags. So again, if we're doing inline JavaScript, which we're not doing, right? But like imagine you were doing it and you set your string text content using the text content assignment property. Then we take away any superpowers, right? So for example, just a second. Yeah, exactly. So if we can set the text or string content by doing the assignment property, that's better because it's not dynamic, it's static, it's not interpreted. I'm gonna give you a list of ones that are dynamic in a few minutes. Yes, there's another example. Okay, so ideally we want to specify that text is text. If we don't specify it, sometimes our systems guess. And it's like, oh, I think that's JSON. That must be data. I'm like, okay. So when the text is from the user, if we use inner text or text content instead of inner HTML, again, those are static rather than dynamic. Inner HTML is dynamic, it's interpreted. It takes what's in there and it's like, ooh, is that code? I should execute it. And we don't want that. We never want confusion. We always want it to be like data's data. Oh, and we should not let the DOM decide for us because it gets it wrong a fair bit of the time. Okay, so when setting element.setAttribute, ideally we would use safe static attributes. So things that don't change. And I know this is really small. So there's like align, a-link, alt, BDG color, border, et cetera, right? But so those are good. And then bad ones, by that I mean dynamic, would be on click or on blur. But I have another longer list. So for instance, event handlers like on click, on change, on mouse. If it says on, then it's dynamic. If like form control values like valued, checked, selected, disabled, read only, href, source, action, form, all of those, like what you put in there can be interpreted. So ideally we would set the text of that rather than putting it right in there. And then on top of that, Boolean flags are kind of weird and wonky. So if you have the attribute and then you set the Boolean to false, it'll still be true because it's like, it's right there. Obviously it's true. I know that sounds dumb. Does that make sense? So like if you set it to true or false, when it goes to look at it, it's like, oh, it's right there, so that's true. And so just that's more like an accuracy problem than a security problem, but inaccuracy can lead to security problems. Okay, more. So when making bad choices, and by that I mean inline JavaScript, do you like how it has like this disapproval look? Like it's your mom when you're a teenager and you've showed up and it's like 4 in the morning and your mom's like, yeah. Anyway, we should set the content type header to application or JSON, not text or HTML, assuming that it is data. And we do that to prevent cross-site scripting. Because if you leave it up to chance, sometimes it's like, oh, you know what? That looks like text, or that looks like HTML, sounds good, when in fact it's supposed to be data. So we want to be specific whenever possible, rather than letting it interpret for itself. Okay, yeah, don't let it guess. So variables, and by that I mean like stuff we got from the user usually, right? So if we have a variable, sometimes we've done some math and we put it in there. But often if we have a variable, at some point, whatever's in there came from the user. So I'm talking about that situation. They should go in the CSS property values. So for instance, not the contexts, because contexts are dynamic and kind of interpreted, where the values are like, that's text, and it just goes there. So it takes away any superpowers. So for instance, style selector property equals this. Oh, and then we close our style tag, because that's what you should do. Okay, so ideally we should use strict mode. Who uses strict mode? Oh man, one day I dream of when all the hands will go up. How many of us are just really tired and our arms are heavy? Okay, so yeah, all right. Okay, so when we have strict mode on, it enforces stricter parsing and error handling, and that is good for security. It also prevents like accidental global variables. It blocks us from using the this function from binding to a global variable by accident. It prevents global scope that's by accident. There's all these things that it prevents. And when things act differently than we're expecting, quite often that can create something called a business logic bug or flaw. And those are things that automated scanners completely suck at finding. That's where you hire a penetration tester and they find it after learning all about your app and all the things it's supposed to do, because that's how they can understand it. And so strict mode helps ensure that there's no functionality that's a little wonky, because a little wonky can turn into a big problem. Yeah, that's all. Okay, so number 19, we want to avoid something called HTTP parameter pollution. So basically, that is where an attacker sends multiple parameters with the same name to your rec.query or rec.body. But the values that they are adding are obviously malicious. They're an attack, right? And then basically what happens is they send these extra parameters, and then if your app does not protect against this, it can execute their attack against you. This is bad. I've had a couple of clients ask about this and have problems with this. Yeah, I've had one that has had this happen to them over and over again, and I'm not allowed saying their name because non-disclosure agreement, but you all know their name. Yeah, and so ideally we could use the HPP module from Express, or there's HPP middleware that you can use that can help protect against this. Or you can write code to defend against it. So that's input validation on the server side using an allow list, so things that are allowed. Then sanitize out any special characters or escape them, your call. And then each of the frameworks that I mentioned earlier, like Vue, Angular, React, you can also configure them to help you protect against this one. This is just a JavaScript problem. Okay. Oh yeah. Oh, and there's a library. So Express Validator, Joy, or Zod. Okay. So DOM Purify is a library or like a third-party component that you can use that protects against DOM-based cross-site scripting. You could write the code yourself, but the person that maintains this has done such a fantastic job that basically everyone ever recommends it. It's very good. And so you should check this out. It's really good. I put the GitHub thing after. You can also message me after and I'll send you the link if you want. But basically, it's really good. You should try it. I don't know the person that makes it. Every single person I know is like, oh yeah, use that. It's the best. Okay, so ideally, we would also use sub-resource integrity, so SRI. Basically, it verifies the integrity of external scripts that you're using. And so basically, so even if it's from a content delivery network, the content delivery network could have been compromised. Like, just trusting things that people send to us, even if we trust that organization, it could be a problem. Someone could have, got between us and them and sent something else. Like there's a lot of things that could have happened. And so SRI checking is a feature that's built into the web browser that uses a cryptographic hash to verify the integrity of the script, to make sure you are definitely getting what you think you're getting. Problems with integrity over the past 5 years have been a huge issue for security folks. It sucks. That's it. Okay, so this is more like a suggestion. You can minify and bundle and then nonce your code. That kind of helps obfuscate it a bit and make it like a bit harder for attackers to get a hold of and read. You don't have to do it, but let's say for some reason your JavaScript's really sensitive and you really don't want people to take it or see it, you could do that. You could use something like Webpack. There's other things you can use. There are products you can buy, but Webpack seems to be kind of popular. We want to avoid also cross-site request forgery. So cross-site request forgery is a vulnerability where the person that is affected they click on some sort of link or they go to a site they shouldn't. And like, please forgive them. This happens, right? I have totally clicked on links I wasn't supposed to at some point. Like, all of us make mistakes. So they click on a link and then they're already logged in to this site. So I don't know about you, but I'm logged into a ton of sites right now. Probably like Amazon, Netflix, stuff like that. And they send a request that's to one of those sites, assuming you're already logged in, and then it goes and does something like buys ugly shoes and charges me for them, but ships them to someone else's house. That is how cross-site request forgery works. And so when you are doing JavaScript, you need to check for that. And so you do this by passing a token back and forth. So basically, some of the front end frameworks, they'll pass the token to the back end for you, but you have to check that you got it. So you just check if there's a transaction. So like a sale, deleting a user, something that you would qualify as a transaction, something that usually is not reversible. That's where you would check your cross-site request forgery token. The frameworks will do it on the front end. You still have to check it on the back end or there's no point. So when I was a pen tester, I'd be like, oh, you're sending the token. No one's checking it. So it's not working. So you have to do both sides of this. And so you don't check it in the JavaScript. You have to send it in the JavaScript. If you're not using one of the front ends, you might need to send it manually or like write the code for that. Okay. I would love it if all of you used a linter, because linters are awesome. They help you have better code, manage technical debt, etc. They're really good. But I'd also like it if, as well, you used a static analysis tool. So in North America, they call it SAST, Static Application Security Testing, because some person at Gartner decided that all the security tools had to rhyme or else. I'm not in charge of that. That's not my fault. But basically, static analysis is a tool that will analyze your code to look for vulnerabilities. I really would love it if you would do both. A lot of times developers say, oh, I'm doing static analysis, and then they list a tool that I consider a linter. Linters are awesome. Don't not use them. They're great. But in addition, a security-focused tool. Also, and then you should fix the things you find, not just delete those results or suppress them or like put them in the backlog and forget about them for the rest of your life. I was banned from Stack Overflow for a while, but I'm unbanned now because I write for their blog, so I could appeal a lot. And one of the reasons I got banned was I was like, I'm going to answer. So I work at a little company called SemGrep, and I was like, I'm going to answer every SemGrep question today. And the bots were like, that's suspicious behavior. And some of the answers it really didn't like. Like this guy's like, how do I suppress this result? And I was like, yo, you have cross-site scripting. This is how you fix your code. They're like, you didn't answer his question. Ban. And so please don't just like suppress the results or ignore them. Actually fix them. It'll be so much better. Dangerous functions. So there be dragons. So these are things I would love you to avoid. Okay. So functions that I would love it if you would avoid. Eval. So eval basically it just like runs whatever you put in there. Inner and outer HTML. It interprets those things. Function, escape, unescape, document.write, unescape HTML, decode URI, encode URI. If we could avoid these, life would be a bit better. If you have a linter tool where you could write rules, you could literally just write a rule or grep through your code and just be like, am I using those? And you could just be like, I'll just use something better. Number 26, if we could stop using the with statement, so most of us don't use it. If you're using strict mode, it is forbidden. But basically, it allows for simplified access to object properties by establishing a default object scope. What does that mean? Basically, they created it to help you avoid having to repeat code over and over again, which sounded really good. But then when they used it, It was so confusing. So if you were reviewing code, it was really hard to tell what was going on. And it made it basically impossible for static analysis tools to do their job. And so then it's like, well, we can't review the code for vulnerabilities and we can't automate looking for vulnerabilities. And it just disables those tools. And we need those tools. So I would love it if you did not use the with statement. We should avoid function constructors with a string argument. And by that I mean, specifically, if we're using a string argument in a constructor, what's in the string? Where did it come from? It probably came from the user. And sometimes people are like, oh, that didn't come from the user. Sometimes that's true. However, a lot of times when, so I teach secure coding, and then I also have done application security and pen testing and stuff like that earlier in my career. And a lot of times when I would find something, the developer's like, that's not user input. And I'm like, so I include in user input anything that could have been changed by a user. So yes, if you have a search field and someone puts something in there, that's obviously user input. But let's say you have a hidden field, I can change that, right? Anything that I could have changed is user input and is therefore suspicious. And everything in JavaScript can easily be intercepted with an intercept proxy, and I can change it to whatever I want in 1 second. It's very easy. And so everything that came from the front end over to the back end can be changed. And so something from an API, maybe that API was compromised. Something that's coming from a third-party library, like all of these things could be not what you think. And so if that is what is in your string that you're putting in your constructor, that is bad. So we would like to avoid that. We should be careful with set timeout and set interval. So if we're going to put, ideally, let's not put user input in them or anything that could have been changed by the user. But basically, yeah, they have some, I don't know how to explain it. Basically, we would like to just not put user input in those. And I'm just going to leave that because I'm going to talk forever. We should avoid JavaScript methods that take code as string types. And so set attribute, set timeout, set interval, or new function. Yes, that's why. So if we allow it to take code as a string type, what is it going to do with that code? It's going to interpret it, right? And then if somehow a malicious actor was able to put something in there that shouldn't be there, we are in trouble. Also, if a regular user just leans on their keyboard, they could accidentally put something in that could break something. My mom is a brilliant woman who is a mathematician chemist, and she has broken so many software programs. So sometimes users just do wacky things that we don't expect. And so we should avoid JavaScript methods that take code as string types. Okay, oh yeah, instead we should set the attribute directly. That's easier. Okay, more. We should not put untrusted data into HTML rendering methods, because guess what it's going to do? It's going to render. And we don't want to render things that our users are giving us. So examples would be inner HTML, outer HTML, document.write, document.writeLine, etc. And I know I mentioned those ones before, and I'm mentioning them more than once because I really don't want you to do them. And I read you have to say things more than once if you want them. Okay, another type of injection. I know. Okay, so Java is a prototyping language. And so we want to avoid prototype injection. And so just a second, I'm going to tell you how it works. Actually, let's just go through how to avoid it first. Okay, so if we can freeze the default object everything else inherits from, then they can't inject into it, right? Because it's frozen. First, step one, awesome. If we could explicitly create objects that don't use prototyping, again, then we don't have this problem. If we could use map instead of object, again, we wouldn't have this problem. Or we could avoid recursive merge functions altogether. And so basically, if an object doesn't have a property directly on it, JavaScript looks up the prototype chain to find it. If an attacker has managed to change the prototype, all objects that inherit from that prototype may be affected. Thumbs down. It's hard because I'm holding this, but imagine that was a big thumbs down. Okay. Ideally, we would not mess with the same origin policy. So the same origin policy prevents websites from accessing data or resources from another website unless it's shared intentionally via something like CORS. We don't want other websites to access our stuff. That is highly unlikely. Unless you're like a content delivery network or something, you probably do not want other people accessing your stuff from their site. That's weird. And so we should not mess with it. And so by that, I mean, do not set the same value for document.domain in order to share information between two pages. We should use CORS like the cool kids. Please don't set window.postMessage to star. That also undoes the power of same origin policy. And lastly, we should check the origin. Okay. And validate whatever is in the message before we use it. Okay, lastly, not lastly, I was lying. True validation should happen on the back end. So when you are validating input, you can totally validate it in the JavaScript, but then you have to do it again on the back end, unless you're doing a SPA, a single page web app. So if you're doing a single page web app, we're going to talk about that after. If you're doing a front end, back end type of situation, front end APIs, etc., like most of us are doing, the security check has to be on the back end that you control. I can get around anything you do in JavaScript. All of the security nerds can do that. All of you can actually do it too, because if you're a software developer, you're very smart, and it would be very easy for you the moment you see someone do it, you're like, I know how to do that. And so we have to check the last time, the final official check on the server. You can do it also on the front end for speed, right? Like people are filling stuff in and you just want it to be super fast and then it looks good, but then you check again. If we're doing a SPA, a single page web app, you have to do all of it in the front end, and validation is more complex. And if you want to talk about it, we could talk about it after. Yeah, front end validation can save time, but you have to do it again on the back end. Okay, seriously. Okay, so we should prefer, and this is for every language, private variables over global. Because when we reduce scope, we reduce risk. And so they're less likely to be accessed by external scripts by accident if we have reduced scope. So they're not global, they're private. That is better. And now I have some tools for you. So all of these are free. So the first one is SumGrep Community, a static analysis tool that works great on JavaScript and I think like 22 other languages. DOM Purify, I talked about that earlier. So it will basically sanitize out cross-site scripting for you. It's awesome. You should use it. It's free. Retire.js. So what it does is it checks your JavaScript libraries to see if they're deprecated or if they have known vulnerabilities in them. So you can be like, nope, not using you. NPM audit, everyone knows that one. Yarn audit, same deal. HoruSec. So HoruSec is another static analysis tool that is a bit older. Node.js scan, Bearer. So Bearer is another one that is like retire.js, where it will check your third-party dependencies and make sure that they don't have vulnerabilities in them. And DOM Snitch. Quite the name, right? And so I'm going to leave this up for just a second in case anyone wants to take a picture of it. Eventually, I should have a QR code so that you can download it, but I just didn't do it. I have spent I arrived Tuesday night and I have been sleeping at the most random times. And usually I'm better at jet lag. This trip I have not done a good job with the jet lag. But anyway, okay, so I have a conclusion for you. Conclusion, what did we learn? We learned about a bunch of insecure functions that we should not use. We learned about better alternatives, so safer functions. So don't use this, please use that, right? We talked a lot about cross-site scripting and the recipe to avoid it, as well as just like many different, more specific ways to avoid it. And a list of free tools, and that secure code really matters. We learned all of those things if you didn't already know them. Okay, and now I have some free resources for you, so you might want to keep your phones out that you had before. So the first one is SumGrep Academy. So SumGrep bought my little company, and we had an academy, and now it's free with different branding. And I've even been able to add new courses to it. So there's secure coding, instant response, functional programming, security headers. We have all sorts of things in there, and everything's free. However, they will add you to the marketing newsletter, which is not the end of the world, in my opinion. You're also allowed to unsubscribe if you need to. Books, I wrote books, they're not free. But me and my mom agree that they're good. We are not biased at all. If you write code, the yellow one is for you. The yellow one is for you. And if you want to run a security program or become an application security engineer, the purple one's for you. You're allowed to read both, but generally, if you're going to start, that's how I would start. If you work in application security, if you could do the survey for me, that would be awesome. If you don't work in application security, you can still do it and answer for your organization if you feel like you know your security program. But basically, I'm doing a survey so that I can release some data. And so far, the results have been like not what I expected. And so apparently, I need 100 to be statistically significant, and I'm at 61, so I'm really close. Oh, yes. Oh, and if you answer it, then you will get a report based on your answers to help you improve your security program. So you get something too, not just me. My friend Clint has a newsletter. It is free. It is every week, and it is security research summaries. So he summarizes all the research he could find from that week and puts it in here, and it has made me look smart on numerous occasions. And then with that, I am Tanya Janca, and if you look up She Hacks Purple, basically all over the internet, that is me. And thank you. Thank you very much. We have a few minutes if anyone wants questions. Also, there are stickers, and then there's like my project links down there if you want them. Do we have any questions? If you're shy, what you can do is come up to me and then I'll talk your ear off. Okay, well, I guess it looks like we don't have any questions. Thank you, everyone, for coming. I really appreciate you, and maybe some of you will talk to me after. Thank you.